Hey everyone, it's Miss Cooperud, back to talk about more dot plots, or line plots is another name for it. This time we're going to look at dot plots and line plots with fractions. So you need the sheet that looks like this, creating line plots and dot plots with fractions. You might have it in person from your teacher, or it's in Google Classroom as well. So I'm going to take a look at number one. We're going to work through number one together. So please pause the video, find the sheet, and come back ready to write on your sheet or ready to open it in Kami and pause and write on it on the computer. All right, welcome back. So we are going to make the X's on the dot plots just the same way we did last time, as in we're going to stack them up higher and higher each time we get another one with that data point. But this time we have to figure out where the fractions are. So take a look at our first piece of data. It's 7.5. So here's our number line. Is it okay that our number line starts at 5 and ends at 8? Sure it is. You'll notice that these arrows on the end, they mean numbers keep going to the left, and that means lower numbers, 4, 3, 2, 1, and into the negatives. And also, there's an arrow over here. That means numbers keep going higher, 9, 10, 11, etc. So when you're showing a number line, it's absolutely okay to just show a little tiny piece of the number line. That's completely fine. So we've got 7.5. Where is 7.5 going to go? Well, we know that there's 7. 7.5 is more than 7. It's not to 8. And half, we know, is pretty easy to find, right in the middle. Now, I'm going to put a little line there. You can label that if you'd like. You can label it as 7.5. Or if you just know what's halfway in between 7 and 8, you don't have to label it. You just want to put a little hash mark there. Then we need to put 1x for 7.5. There it is. The next one is 6.5. We're going to do the same thing with 6.5. Pause, put it in, plot it in, and come back and see if you agree. All right. Do you agree with me? It's in between 6 and 7. There it is right in the middle. And we have 1x. Our next piece of data is 7. We put that right above the 7. Notice I'm trying as much as I can to keep all the first levels all the same. I don't want to have them some high, some low, some high, some low. Makes it hard to easily see the graph. So you want to try to get them all about the same. Now, when we go to, there's a 6. Now let's go to here, 7.5. Remember, when we have a second piece of data that goes right on that same line, we bump it up and now we're making like a second row. So there's 7.5, makes a second row. There's 5, that's in the first row. 6, same thing with the 6. Here's the 6. Now it's going up, so I want to kind of try to keep it as much as I can, roughly level with the other one to keep myself organized. So pause and see if you can plot all of the data and then come back to see if you agree with me. All right. Take a peek at what yours looks like. Does it look kind of like mine? I hope it does. If you see mistakes, are they my mistakes? Shout out to Cooper. He found a mistake for me on the last video. Good job, Cooper. If you find some of my mistakes, please tell me, hey, Miss Cooper, I think you made a mistake. And I will, because I'm human. Or are the mistakes yours? See if you can figure it out. If it looks exactly the same, we're probably in the same boat. All right, now let's find the mode for that particular set of data. The mode, remember, is which one has the most examples of it. Which one occurs the most frequently? Well, it's tricky because there's 3 5s, there's 3 5.5s, there's 3 6s, and there's 3 7.5s. So what is the mode? If you said it's all of those, you're right. You can have more than one mode. So in this particular case, the mode equals 5, 5.5, 6, and 7.5. Nice job. I also want to tell you today about another way to talk about data. It's called the range. And range means the amount all the way from the biggest all the way to the smallest. How much difference is there between the smallest piece of data and the biggest piece of data? So let's take a look. Our smallest piece of data is 5. Our biggest piece of data is not 8. Don't get confused. 8's on the number line. but we don't have any data that was an 8. So our biggest piece of data is 7.5. So what is the amount of space? How many numbers are covered if we go from 5 to 7.5? The range you could think of is the biggest number that's in the data set minus the smallest number that's in the data set. And that tells you how much difference there is in all of the data. In this case, the range equals 2.5. Let's try another one. All right, let's look at number 5. Down at the bottom of that first page, there it is. You've noticed that I've plotted 5, 6, 7, 8, and I've only put the first couple of pieces of data up. That's okay, we've got a lot of data to plot. So let's take a look at the first piece of data, 7 4/8. Now, if you're kind of looking at it and you're a little bothered, you're kind of like, wait a minute, I know 4/8. I already know 4/8 is a half. Can I just plot it at 7.5? The answer is sure, absolutely, go ahead. But we are going to need to know if we see our data has eighths in it, we're going to have to divide the spaces in between the whole numbers to show eighths, because not all of them will be as easy to plot as 1/2. So 7 4/8, we know that's easy to plot, right in the middle, and that's a half. You could label it a half if you want. That's actually really great. If you would prefer to label it 4 out of 8 pieces like they do in our data, that's fine. Fantastic. So go ahead and put your first x at 7.5. 5 4/8, same thing. Again, if you say 4/8, I know is a half because 4 out of 8 pieces is half of the thing. You again could go right in the middle for a half. You could label it as a half. As a matter of fact, when you're thinking about measurements, very often they don't show things that are like a half. They don't show it as eighths or sixteenths. They want you to know that that's half. But if you say, no, I'm just getting started and that it's harder for me to think about it than just to know that 4 out of 8 would be halfway across, I want to name it 4/8, go ahead. So there's that one. And again, I'm trying to keep all the first levels even. Take a look at 6, the next one, 6 1/8. How are we going to plot that? Well, we're going to need to cut that space between 6 and 7 into eighths. Pause and see if you can figure out how to do that and come back and see if we agree. All right, I want to show you how I divided this up between 6 and 7. I did a half, and then half of a half is 1/4, so this is 6 1/4. And then the other half of the half, that means it's 3/4 of the way across. So I did 6 3/4. And then I'm going to actually just make little lines right in between there. And I'm not even going to label those because it gets a little crowded on my paper. If you've got a lot of room to label it, you're absolutely welcome to do it. But I'm not going to do that because I know that I've now created it into 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then on the next whole number would be 8/8. So when I plot 6 1/8, I'm going to put it right above the 1/8. Now, when I notice how small the spaces need to be and I look at all the data, I say to myself, ooh, I might need to go back and make my x's a little smaller. I might not be able to make gigantic x's and have them all fit. So I might need to make these x's a little smaller. If that happens to you, it's all right. Now, I didn't write the rest of the data here, but you have it right here on the last one. Go ahead and figure that out. Then see if you can figure out also from this data the mode. Remember, there might be more than one. That's which one has the most iterations of that particular number, not necessarily the biggest number, and see if you can find the range. How much is from top to bottom. What's the span of the data from the whatever it starts at the very bottom, all the way to the top? You might think of subtracting from the biggest number, subtracting the smallest number. And remember, it might not be 5 or 8. That might just be where the number line is. You'll have to see what the actual data show. Now, when you're done with that, go ahead and come see if you can finish this page for your skill card. If it's super easy and you blow through it, go ahead and give the next page a try if you've got some time, but that's not expected. So just if you're like, oh, yep, I get in this, I'm blowing through this, see what you can do. Or you could also say to yourself, could I find the mean or the median? If you remember that from last year. See you next time.